Hello everyone, it's me Murli. In my previous video, we have seen how to do the data preparation for a products entity for a use case called grocery stores or Microsoft Fabric. Now, in this video, we will see how to do the data preparation for address entity. Okay, so what we do here, guys, we first, as usual, import the necessary libraries. And then I got some set of names. These names, I would like to use these names for street names, and the similar names I would like to use for the customer names in various scenarios. So this is a generic names dataset. I just got it from internet. Got some set of 100 names of first name, middle name, and last name for male, and 100 names of each first name, last name, and middle name for female as well. So that's what you see here. Yeah, so we got some data set like this in a Python list. I run that Python list, and then I define the schema for that one, which is name, name type, and gender. I run this one as well. I got the names temp view as a temporary view. Now I use this names temp view in the subsequent cells. Now we'll see how to generate the addresses dataset. For the addresses dataset, I took some 100 cities of United States with some random postcodes like this for each state. If I run this city data, again that was executed. The first column is city, second column is state code, the third column is state, and fourth column is postal code, and the fifth column is country. So I got a schema defined, and I named this particular data frame as cities temp view. The data frame is df_ cities, and I got a temporary view on top of it, cities temp view. So I run this. Once after I executed that, I got some output, and this is how the data looks like. The city, state code, state, postal code, and country. Once after I see this output, then I derive the addresses data. In each city, there may be lots of streets. So what I did, I used some technique of cross joins because we want to generate millions of addresses. So how to generate millions of addresses? This is one of the technique. What I did here in this, I said select explode sequence 100, 200, which I want to use it for a street lane. And our lanes will be 100, 101, 102, up to 200. And here I took the distinct of names from the names temp view, and I suffixed them as street. So this is how I got names and the street. Here we got some list of cities. So when I cross join this data set, this one with L, names with N alias, and cities with C alias, I got some columns here, which I pasted them here. And I put this total output in an inline. And here we got all those column names. I concatenated the lane with the street name. I named it as address line 1. Address line 2, I just made it as a blank. I generated some address ID. I execute this data frame. That data frame is ready, and I called it as addresses temp view. When I say select those column names from the addresses temp view, you see the output something like this. See, this is and it has it did the cross join of all these three different data sets, and it has first listed the first 1,000 rows something like this. And observe this. This is the street name, this is the line, this is the lane, 100, 100, 102, like this, and this goes up to 200. So 200 lanes in one street. Again, it starts with another street, again 200. So it goes on. After that, if you observe the total count, I executed it before, and it has come to nearly 4.35 million, right? So it's a huge data set, huge list of addresses. What I do, whenever we have huge data volumes like this, it's better to persist that data set. Now I want to introduce how to create tables as well in the Lakehouse. So I run this. I said create or replace table addresses using delta in a delta format. As select, these are all the column names from addresses temp view. When I did that, now it is running, but what we should see here is under this Lakehouse, here we got tables. Under these tables, if we right click and refresh it, we should be able to see the addresses table. Please bear with me. Okay, so here we clicked on the create or replace and we let it execute. It took a minute 45 seconds to create a table from that particular data frame. And after that, you should come here into the tables, right click and click on refresh. So we see the table. The table has all these columns, right? I use the table in the next data frame like this here, and then I generate a CSV file. And how I generate? Whatever the function which we have before, the generate CSV file function, will use it. Let me see. First, let me execute this data frame, and then I don't know whether I need to actually look for that particular function which I have created in the previous session. Please bear with me here. This is the function, and I run this cell. So we got this generate CSV file. I'll come back to these addresses and I execute that. I execute it. So what we are doing is, because it's a huge volume of data, if I want to regenerate multiple number of times, it's better we persist the data. So I have created that data as a table within the Lakehouse Explorer as a Delta Lake table, and from the Delta Lake table I'm generating a CSV file. Once after it generates the CSV file, I will show you where it generates. And here again I have used this particular location of files, and then under the inbound there is addresses. So under the addresses folder in the inbound, the file will be created with the prefix as addresses. So please bear with me, it is running, and now it is done. Once this is done, right click here and say refresh. So we got these addresses here, and these addresses, we click on the other tab where we got the Lakehouse open, right click, refresh it, we got addresses data, click on the addresses and we get this addresses data. And this addresses data is it has generated around 385 MB and it is showing here around 10 MB in the preview. And go back to the notebook, and I think we can end the session here before we move on to the other entity. Thank you.